Hi everyone, this is R.V. Kiran, Assistant Professor, Department of Mechanical Engineering, Chevrolet Engineering College. Today I am going to deliver a lecture on advanced materials, and the topic in the lecture is functionally graded materials and its introduction and origin of FGM, that is functionally graded materials. So these functionally graded materials are the latest edition of composite materials. So advanced concept of the composite materials which we are using in the research purpose as well as the industrial purpose also for own purpose. So for own purpose. So in the first slide we are going to discuss about the introduction of FGMs, that is functionally graded materials, and these functionally graded materials are new class of composite materials which is also known as the FGMs, and it has considerably drawn attention of the scientific community because of their properties and existence in the nature also. So FGM exists in the nature like wood, bamboo, etc. Even in the human bones also it has some FGM. So there are number of layers and type of layers. So it is existing in the also human bones also. Next one is the aircraft and aerospace industry and the computer circuit industry make wide use of FGMs that can withstand very high thermal gradients. So in the figure you can see about the different layers of the FGM. So it has the sapwood and hardwood and vascular cambiums and bark, that is living phloem and pedum, and next one is the cork. These are the different types of layers which we have seen in a natural wood. So in the natural wood also we are seeing a different number of layers there. So there are core and layer by layer division of the wood. So these are the natural FGMs, natural functional graded materials. So if we want to make a graded material by varying the composition of microstructure from one material to another with a specific gradient. So specific gradients means with a property defining in the layer. So in the right side picture we are seeing the dense layer of the part and porous layer of the part also. So this is a human bone which we are seeing the porous and dense properties together in a single structure. So this enables the FGM to have the best properties of materials where it is needed. So when we want to have a dense layer on the top of the structure and porous layer in the center of the structure, we use it to define through FGMs only. So these FGMs are composite materials which are designed to present a particular variation of their properties. So we use it to define a particular property, that is which is a tensile strength or compressive strength or hardness or specific strength. So there are different types of properties are there in a material. So we use it to define a variation in the properties, we use the FGM, and this is also achieved by forming a compound of two components. So compound means mixing of two components whose volume friction is changed across a certain direction, that is x direction, y direction or z direction. For example, the toughness of a material can be mated with refractoriness of a ceramic. So we are mixing the metal with a ceramic, so that is to give a toughness to the surface of the layer without any compromising in the metal refractoriness. So we are using the ceramic structure there. So these are one of the type of FGMs, and we used to define the other structure or other property on some other layer. We used to define the other material also. So these are the basic examples of the functionally graded materials. So the characteristics of the main characteristics of the functionally graded materials are to define the different properties in the same structure in different areas. So here we are seeing the development of these materials and metals. So in the olden days we are using the pure metals and non-metals there. So pure metals and non-metals. So metals means copper, iron, stainless steel. These are the metals. Non-metals means some other. Next, by improving from the metals, pure metals, we have defined a alloy. So alloy is a combination of two or more metals combined to form an alloy. So in that alloy also there are only pure metals or non-metals are there, no materials are there. By developing from the alloys to composites, these composites are made of two or more materials combined to form a composite. So two or more materials, that is polymers or materials, polymers or metals or ceramics or foam. So there are different types of materials are there. So when we combine the two or more materials, then it will be a composite. And the latest edition of the composites are functionally graded materials. So these latest edition of the functionally graded materials comes under the development of composites. So these development in the particular sections, that is layer by layer or some part of the layers or some part of the structure. So next one is the origin. So where we can firstly find the FGMs. So the first FGM was developed in the first FGM was developed in the Japan in 1984-85 as the result of space plane project. So when they are defining the properties to a space plane, they have defined the special property known as the FGM. So although the concept of FGM is recent, many materials have described from the decades. So last decade or last before decade, they have been defined through these type of materials. And some naturally occurs FGMs, so not the artificial one. The naturally occurring FGMs are, first one is bones and teeth, which is in the human as well as animals, and seashells, which is obtaining in the sea. Next one is the bamboo tree, and fourth one is the human skin. So these are all the naturally occurring FGMs. So these all combined a separate number of layers. So different types of layers are forming in these naturally occurring FGM. So when we use to define the skin, human skin, there are number of layers. So that is why we are defining these as naturally occurring FGMs. So some naturally occurring FGMs are, first one is the skin structure. So when we use to define the skin path of the human skin, so here we are seeing the human skin. So first one is the primary layer, second one is the dominant layer or epidermic layer. Epidermis, we use to define it as epidermis, and next one is the basement membrane, and last one is the anchoring libris. So these are the different structures or different layers of the human skin. Next one is the bamboo stick. So next one is this cells occurred in the bamboo stick. So lamellae, canunculae, cement line, these all are in the bamboo stick. So these are the microstructures of the naturally occurring FGMs. So where we are defining the naturally occurring FGMs. So first we use it to define the difference between the composite and FGM. So the last edition of the developed materials are composite, and the latest edition is the FGM, functionally graded materials. So when we use to define the difference, first one is the shape interference between the materials, so sharp properties can be changed. But in the FGMs, the smooth transition between the materials can be occurred. But going to the risk of delaminating the layer under extreme working conditions, but FGM can consist very good bond between the materials. And third one is the matrix. So change of matrix. So in the composite, the matrix and the reinforcement are very lesser or weaker in stage, and weakness and strength of both materials are present everywhere. But in the distribution of the FGMs, spatial properties can be distributed, and also possibility to tailor a material for specific application. So if you want a defined property, we used to get a defined property, we used to get or develop these FGMs. So all are under a bit thermal conductance, and matrix lost a bit of hardness. So this consists of the matrix also in the composites. So in the matrix form, the hardness will be somewhat lost, but in the FGMs, you can see the right side picture of the slide. There are two colors, that is the leaf green and the mild blue color. So this green color region is largely hard, somewhat extended to the blue color layer, and the blue color layer is largely thermal conductivity. So it consists of some thermal conductivity, and green color layer is the has large hardness. So large hardness is there. So there you can define the different types of properties there. So you can define the different types of laminas and different types of properties in a single structure. So next one is the FGM structure. So this is a continuous structure we are seeing here. So first one is the ceramic phase, and developing on the phase, it is mildly increased with the ceramic matrix with metallic inclusions. So we are adding reinforcements as metallic inclusions. Then going to the transition range, so we are changing the phase. So we are going the ceramic phase to metallic phase. So this is the transition region where it is developed as 50-50 percentage. So 50% ceramic phase and 50% is the metallic inclusions. Next one is metallic matrix with ceramic inclusions. So the major part of the region consists of metallic matrix, and the minor part is the ceramic inclusions, and last one is the metallic phase here. So we are starting with the ceramic phase and ending with the metallic phase. In between these there are three types of phases, and developments have been added their stages. So first one is the ceramic matrix with metallic inclusions, that is major part of the matrix is developed by ceramics and minor part is the metallic inclusions. Next one is the transition range, that is which is divided equally, that is half of the part is 50% of the part is ceramic phase and 50% is the metallic inclusions. Next last stage is the metallic matrix with ceramic inclusions. Major part of the structure is metallic matrix and minor part is the ceramic inclusions there, and last one is the metallic phase. So here we seeing the continuous phase here, and we can see, we can briefly explain in this slide also. So there are two types of punches here, upper punch and the lower punch in the taken die. So we are taking a die with upper punch and lower punch. So we are making a material with 100%, so 100 grams of A material and 100 grams of B material. So starting with the 100 grams of B material, first layer is the darkish blue color, 100 grams of B material there. Next, developing to the first stage, we are adding the 20 grams of A material with majority inclusions of 80 grams of B material. Next one is the transition stage. So in the transition stage here, A material is slightly higher than the B material, that is 60 grams of A material is added with the 40 grams of B material. Next one is the fourth stage, 70 grams of A material added with the 30 grams of B material. So after the transition stage, it is the phase change addition. And last one is the 100 grams of A material, that is totally changed into the other material. So we have started with the B material but ended with the A material. So this is the basic structure of the FGMs. So in any FGMs, the structure can be defined as follows. So in the right side bottom corner, we are seeing the colors of the addition. So that is the material A and material B. Material A means that is in the pink color, and material B is in the mild gray color, that is darkish blue color. So on the right side we are seeing the FGM structure here. So in the FGM structure, many types of layers have been added here, that is we are seeing with the different color combinations here. Next one, why we are using these FGMs over composite materials and alloys and other metallic phases, so pure metals or non-metals. So why we are using these FGMs in the larger quantities? So large number of engineering components and tools require material performance by varying the location. So already we have discussed about the structural basis of the FGMs. So when we have to define a property in the particular section, we are adding that property in the particular section. So but in the composites, we are not doing that in the direct way. So we are mixing or adding the materials as reinforcements also only, but in the FGMs we are adding the property in the defined structure. Second one is the body of the gear must be tough, whereas its surface must be hard and wear resistant. So the body must be tough and the other body, that is the outside surface, will be hard and wear resistant, that is అరిగిపోవటం. సో వేర్ అంటే అరిగిపోవటం, అరిగిపోవటం అనేది తక్కువగా ఉండాలి మనకి. సో గేర్స్లో ఏంటంటే ఎప్పుడు రెగ్యులర్గా రొటేట్ అవుతూ ఉంటుంది కాబట్టి మనకి, సో వర్క్ అనేది జరుగుతూ ఉంటుంది కాబట్టి, వర్క్ పవర్ అనేది ట్రాన్స్మిట్ అవుతూ ఉంటుంది కాబట్టి వేర్ రెసిస్టెన్స్ అనేది చాలా ముఖ్యం. నెక్స్ట్ వన్ ఈజ్ ది నెక్స్ట్ ఎగ్జాంపుల్ ఈజ్ ది ఏ నైఫ్ నీడ్స్ ఓన్లీ టు బి హార్డ్ అట్ ఇట్స్ కటింగ్ ఎడ్జ్, ఎల్స్వేర్ ద మెటీరియల్ మస్ట్ బి స్ట్రాంగ్ అండ్ టఫ్. సో నైఫ్ ఎడ్జ్ మాత్రం షార్ప్గా ఉంటే చాలు కటింగ్ ఎడ్జ్ వరకు, మిగతా మెటీరియల్ అనేది స్ట్రాంగ్ అండ్ టఫ్నెస్ అనేది ఎక్కువగా ఉంటే సరిపోతుంది అనమాట. సో దట్ ఈస్ ద property defined there. Next one is the many of the most demanding current applications are fall under this category only. So with the above properties there, with the above defined properties, so current applications have been using this type of categories only. So they want the different types of structure in the concerned layers or concerned structures. So they are using the FGMs as first preferred material. Next one is the stress concentrations are reduced if the transition from one material to another material is gradual. So what is gradual? So gradual means step by step procedure of the concerned property in the material. So the stress concentration, if the stress concentrations are reduced in the layer by layer, the effectiveness of the material will be developed there. So that is the main property here. So if the transition from one material to the other material is gradually increased or decreased, it will be developed as the good material or defined material. And last one is the magnitude of thermal stress at the critical locations can be controlled. So the different magnitudes of the thermal stresses at critical locations, that is critical locations means at the boiling point or the melting point in the different phase transformations of the iron carbon equilibrium diagram or stainless steel diagram. So we are using the different types of components there. So the thermal stresses at the critical locations should be controlled there. So that is why we are using these FGMs over composites. So different types of composites we are using these FGMs.